Hello everybody and welcome to exercise 1 on page 8 of the workbook. And in this exercise, we're going to look at a function, no formula or graph, just kind of a qualitative situation, and see if we can conceptually talk about things like graphs and cross-sections for this function. Okay, so let's take a minute and just read the situation together here. So they're giving us a function capital T equals f of little d and little t. 3 variables involved. Capital T represents the temperature in degrees Fahrenheit of a room T minutes after a heater is turned on and at a distance of d meters from the heater. Okay, so we're kind of keeping track of temperature, and temperature is going to depend on 2 different things. Number 1, how far we are away from the heater, that's the d, and number 2, little t, the amount of time that's gone by. Okay, and all parts of this problem are about that situation. So let's start with part A here. Take a look at what they're asking us here. So the first part of that question asks, is temperature an increasing or a decreasing function of time? Okay, so they're kind of asking us to think of the distance from the heater as being fixed. It's going to be constant, and we just want to think about how the temperature in the room is going to change as time changes. Okay, so just to help you picture this situation, imagine that you've got a nice chair, and you're sitting in this room with the heater turned on, and I want you to imagine that you just pick a position away from the heater, a fixed distance, maybe it's 1 meter away from the heater, and ask yourself, if you sit in your chair in that position and time goes on, what should happen to the temperature? Okay, well, the heater's on, so the room should be heating up, which means that the temperature should be increasing. That kind of makes sense logically. All right, so let's answer the first part of the question. T should be an increasing function of time little t. Okay, because if you pick a constant distance from the heater, the room should heat up with time. So let's say it this way, at a constant distance, from the heat source, okay, the room temperature will increase as time goes on. Okay, so temperature is an increasing function of time. All right, and now for the second part of the question, they'd like us to sketch some cross-sections. Okay, and we want cross-sections where d, the distance from the heater, is fixed. Okay, so the pictures that we're going to draw then are going to have 2 variables to them. Okay, there's going to be time in minutes on this axis, and there's going to be temperature in degrees Fahrenheit on this axis. Let's take these distance values one at a time, starting with d equals 1. Okay, we're going to fix that value. So imagine that you're sitting in this room in your chair and you're 1 meter away from the heater. Well, we kind of already discussed this situation and convinced ourselves that the function should be increasing. Okay, so just roughly speaking, it's going to kind of have this sort of a shape to it. Okay, we don't know for sure what the shape of the graph is, whether it's concave up or down. I don't know that we have enough information to answer that, but we do know that it makes sense that that temperature should be increasing as time goes on. Okay, what about the next d value? Okay, d equals 2. Okay, so now you want to imagine that you take your chair and just move it 1 meter farther away from the heater. So now you're 2 meters away from the heater. Okay, what would be different about that situation if you kind of sat 2 meters away from the heater and watched the temperature change? Okay, well, if you think about it, the temperature should still increase because the heater is still on, but you're farther away from the heater. And so it kind of makes sense that the temperatures are going to be lower in general, 2 meters away from the heater. So I would expect a curve that kind of has the same shape as the first one, but it's going to be a little bit lower. Okay, because we're farther away from the heater, the temperatures are not going to quite be as large at the same times. Okay, and then by the same logic, if you move 1 meter further away from the heater so that you're 3 meters away, you're still going to increase, and you're going to experience an increase in temperature, but it's going to take longer to reach the higher temperatures because you're even farther away from the heater. Okay, so very roughly speaking, those are what those three cross sections would look like. Temperature is going to increase with time in each case, but the graph is going to be a little bit lower if you're farther away from the heater. Okay, good. So I think we have finished with part A. Let's move on and look at part B here. Okay, so the first part of B asks us, now, would temperature be an increasing or decreasing function of D, the distance away from the heater? Okay, so to help you picture this situation, this time I want you to imagine that you can freeze time in place. Okay, I'm just going to pick a time out of the air, maybe 5 minutes, t equals 5 minutes after the heater is turned on. Okay, and imagine that you're on a chair with wheels now, and you start out right on the heater, distance of 0 meters away, and you kind of give yourself a little push so that you can roll backwards away from the heater, so your distance increases. All right, what's going to happen to the temperature as you roll away from the heater? Would it increase or decrease? Well, it kind of makes sense that it should decrease because you're getting farther away from the heater. All right, so I would expect temperature to be a decreasing function of distance. Let's start out there. So temperature is a decreasing. Did I just say increasing? I hope not. I meant decreasing. Temperature is a decreasing function of D, simply because the temperature should decrease as you get farther away from the heater. Okay, good. And now, just like in part A, they'd like us to draw the graph of some cross sections. Okay, and in this particular situation, we want to graph temperature as a function of distance and think of the time as being fixed. So we're going to have distance in meters down here and temperature in degrees Fahrenheit up here. Okay, and this time I'd like to go in the opposite order of the t values actually. So let's start with t equals 10 minutes. Okay, so imagine that you can freeze time in place. T equals 10 minutes after the heater is turned on. Okay, and ask yourself as you get on your chair starting at the heater and kind of roll away from the heater, the temperature is going to increase or decrease. Well, we already answered that question and said it's going to decrease. So we should get a curve that kind of looks like this. Temperature is going to decrease as distance increases. So that would be the cross section that we're calling f of d in 10. Okay. Again, we don't know that that's exactly what it looks like, but that's just a rough idea. We know that it's decreasing. All right, and then moving on to a constant time value of 5. Okay, so what if we were sitting in the room after 5 minutes after the heater is turned on? Okay, we still know that the temperature is going to decrease as you move away from the heater, but how would this cross-section compare to the one that we just drew? Okay, well, it kind of comes down to asking yourself, what do you think? After 5 minutes, is it going to be cooler or warmer in general in the room? Well, 5 minutes is not as much time for the heater to be on, so it kind of makes sense that the temperature should be a little bit less after 5 minutes. So we're still going to get a curve that's decreasing, but the temperatures in general are going to be lower after 5 minutes than they were after 10. Okay, so I'd expect a curve maybe of that general shape. Okay, and then finally, we come to t equals 0. That might be the most interesting case of all. Okay, what's special about the number t equals 0? Well, that's the instant that the heater gets turned on. So at t equals 0, the heater has had no chance at all to heat up the room for us. Okay, so if you're sitting in the room at time 0 before the heater has been turned on, and you get in your rolling chair and you roll away from the heater, how is the temperature going to change, do you think? What would make sense as you move away from the heater? Well, maybe a reasonable assumption would be to say that since the heater hasn't been on in this room, the whole room is going to be cold, and it's probably going to be equally cold, which means that the temperature actually shouldn't change. It's 0. It's going to stay constant. Okay, because of the fact that if the heater hasn't been turned on, you're going to be equally cold everywhere in the room, no matter how far away you are from the heater. Okay, and I think that completes our analysis on this problem.